Hi guys, today our concern is about the introduction to parallel computing. First of all, we are gonna see what is parallel computing. Traditionally, softwares have been written for the serial computation. They have to be run on the single computer and have a single processing unit. Uh, a problem is broken into the discrete series of the instructions. Third one, we have the instructions are executed one after another. Only one instruction may execute at the moment in time. What is parallel computing? Parallel computing is the simultaneously use of the multiple computer resources to solve a computation problem. It is accomplished by the breaking the problem into the independent parts or into the chunks so that each processing element can execute its parts of the algorithm simultaneously with others. Let's we have diagrammatically representation here. What is parallel computing is also the computation problem should be so it solved in the last time with the multiple computer resources then with the single computer resources. Next one we have the computer resources. What are the computer resources that we are discuss here are the single computer with the with multiple processor, several network computers, and the combination of the both. LLN lab parallel computing is that the each compute node is a multiprocessor parallel computer, and multiple compute nodes are networked together with the infinity band network. The real world is the massively parallel. We are gonna see what are the examples that we see in real. In the natural world, many complex interrelated events are happening at the same time, yet within a temporal sequence. So, the compared to the serial computing, parallel computing is much better, as it's suited for the modeling, simulating, and understanding complex real-world phenomena. If we see, there are the galaxy formation, climate changes, weather, drive-through lunch. These all are the examples. Jet construction. These all are the examples of parallel computing. Let's see what are the uses for the parallel computing. First, in the field of the science and engineering, historically, a parallel computing has been used for use to model the difficult problems in many areas of the science and engineering. Atmosphere, earth, environment, physics, chemistry, bioscience, circuit design, microelectronics, defense, weapons, electrical engineering. In all fields, parallel computing is used. And now let's see in industrial and communication and commercial levels. In industrial and commercial levels, commercial applications today commercial application provide an equal or the greater driving force in development of the faster computers like data mining, oil exploration, web search engines, advanced graphical and virtual reality, and collaborative work environment, pharmaceutical designs. These all are the industrial and commercial use. Why we use parallel computing? We use parallel computing to save our time and money. So in theory, throwing more resources at a task will shorten its times to the completion with the potential cost savings. And next is the parallel computers can build from the cheap and commodity components. Uh, it also solve the large problem which are complex, that is are impractical or impossible to solve them on a single computer. So especially given a limited computer memory, problem solving like petaflops, and petabytes of the computer resources, web search engines, and the database processing millions of the transactions per second by using the parallel computing. It also provides concurrency. A single computer resources can do one thing at a time. So multiple computer resources can be doing many things simultaneously, obviously, like the access grid, which is www.accessgrid.org, provide a global collaboration network where the people from around the world can meet and conduct work virtually. We have the use of non-local resources, using computer resources on the wide area network or even the internet when local computer resources are insufficient. First, we have the set I at home, folding at home. Next, it also limit to the serial computing, which is transmission speed, and limit to miniaturization. Transmission speed. The speed of the serial computer is directly dependent upon how fast data can move through the hardware, and absolute limit the speed of the light, and transmission limit of the copper wire, and increasing speed. Next, limit of the miniaturization, which is the processor technology which allow an increasing number of the transistors to be placed on chip. It's also limits to the serial computer like economic limitations. It is increasingly expensive to have the single processor faster, using a large number of the moderately fast commodity processors to achieve the same and the better performance, which is less expensive. In the computer architecture, currently they are increasingly relying upon hardware level parallelism to improve their performance, which is considered the multiple execution units, pipeline instructions, multi-core. And multi-core, that's it for today. Let's discuss next in the next video. Thank you.